Now is the moment to describe the visions of the users. We must identify real-world objects. One good suggestion is to pay close attention to the nouns that users mention within their descriptions. For instance, invoices, clients, products, and subsequently represent them as GeneXus objects. GeneXus developers do not work by designing tables, normalizing, or programming. Their work is a high-level activity that involves describing the user's reality. Then GeneXus analyzes the created objects and automatically designs and defines a normalized database, creating the application programs automatically for the chosen platform. Let's assume the pharmacy that requests the application needs to register every product it has available for sale, saving for each one of them its identifying code, name, the price of sale, and the stock that is available. For that, we need a GeneXus object of the transaction type, where each attribute or field corresponds to the information we want to register. It is possible to define the transaction manually. We should remember that GeneXus Next provides an artificial intelligence assistant to help us and simplify our task. We will go to the assistant section and inform it that we need to register products, each one with its identifying code, name, sale price, and available stock. In response, the assistant informs us that a transaction object must be created with the attributes mentioned, and we see the product transaction created. If we navigate to the structure sector, we see the attributes that were indicated. We can modify the assistant's definitions. For instance, the names of the attributes. We will change product code to product ID. A transaction is composed of different sectors, and it is within the structure where the attributes or fields that describe a real-life object are defined. Observe that the first attribute has been defined with the icon of a key. This is due to the fact that in every transaction, an attribute or a set of attributes must fulfill the function of a unique identifier or primary key. The objective of this concept is to identify a product in a unique way. This means then that no end user of the application will be able to register two products with the same identifier value. The identifier attribute in our example is the product code. It is important to mention that the names of the attributes follow a nomenclature that establishes as a prefix the name of the transaction followed by the concept that it represents. This nomenclature facilitates understanding when reading an attribute name, wherever it is, and thus being able to know which object is being described. Additionally, each attribute has the data type it can store defined, such as numeric, character, date, image, or others. Notice that the numeric data were defined with 4, 10, and 6 digits, and the name with the maximum length of 80 characters. Let's suppose we want to modify this definition and indicate, for example, a maximum length of 30 characters. The pharmacy also requests that prices be defined with a maximum length of 9 digits with 2 decimals. Now, since we will possibly need to define more prices or quantities, either when the pharmacy buys or sells products, it would be a good criterion to be able to make a generic definition for all prices. To achieve this, in the type column, we simply add the name price followed by the equal sign in front of the data type we have selected. We see that the attribute has been defined with the type price. This definition of the price data type with 9 digits and 2 decimals is called a domain. Domains are generic definitions that have the advantage that if at any time it becomes necessary to modify the definition of prices, that change is made at the domain level, and all attributes based on that domain will be updated. To see all the domains created in the knowledge base, we navigate to View, Domains. GeneXus. Next, automatically created several domains. When selecting any of them, the Properties window updates, showing the properties that apply to that domain. From here, we can not only modify the data type, but also many other important properties. This properties window will update every time we select another domain, object, attribute, control, and so on, with the corresponding properties available for configuration in each specific case. All right, back to the transaction. Starting from the definition of the structure of a transaction, GeneXus Next automatically designs its web interface or web layout. This web interface will allow users at runtime to add, update, and delete products. For its part, the source sector allows working with the transaction in text mode in such a way that the definitions made from the structure are reflected in the source and vice versa. Now, the pharmacy also requests to register the product type associated with each product, and thus know if it is a medicine, perfume, cosmetic, etc. We ask the assistant for help again and tell it that we need to create the product type associated with each product. It responds that to achieve this, it is suggested to create a new product type transaction with an ID and name, and modify the product transaction to establish a relationship between both. Let's analyze this suggestion. Is it correct to define a new transaction for registering the product types? Why is it not convenient to simply add a new product type attribute to the structure of the product transaction? Because if the users wanted to add two products of the same type, they would have to enter the same type 2 times, being very careful to enter it exactly the same. Down the line, it may become necessary to look up every single product of a specific type, which mandates that all those types are spelled out identically. It appears much more sensible to input the product types only one time within one designated area and subsequently link every product to its appropriate product type. Our assistant's suggestion is correct, so we tell him yes to go ahead and do it. And we see the new product type transaction created with the product type ID attribute as the identifier and the product type name attribute. Let's observe the auto number property of the identifier attribute. It has the value true by default. In this manner, every product type entered during the year will be automatically enumerated in sequential order. As we have already mentioned, each transaction has its web interface automatically designed by GeneXus Next according to its structure. Here we see the product type interface. Let's now analyze the relationship defined between product and product type. If we pay attention to the assistant's response, it notifies us that it incorporated a reference to product type within product, utilizing the product type ID attribute. Let's pay attention to these attributes. Product type ID is the primary key in product type. Therefore, when a primary key is included in another transaction, GeneXus understands that this attribute holds the role of foreign key there. Including the primary attribute of one transaction in another transaction allows for relating both transactions. GeneXus establishes relationships via the attribute names. As a result, if it encounters attributes bearing identical names across various transactions, it presumes they refer to the identical concept. What happens with the product type name attribute? It is also present in both transactions. However, it is not marked as an identifier in any of the defined transactions. Therefore, GeneXus will understand that it is a secondary attribute. Thus, the product type name will be incorporated into the physical table named product type, but not in the physical product table. It is very important to be clear that talking about a transaction is not the same as a physical table. The transaction represents the GeneXus object we construct within the knowledge base to accurately model a real-world object. When considering its structure, and the other structures of the transactions already defined in the knowledge base, GeneXus ascertains which physical tables, along with their corresponding attributes, it needs to generate in the database. When the final user runs the product transaction, they will need to input a value for the product type ID attribute that is already present in the table containing the product types, because the product type ID functions as a foreign key within the product transaction. If that is not the case, an error message will be displayed. If a valid value is entered for product type ID, the value of product type name will be obtained automatically and displayed on the screen. In the next video, we will execute the application for the first time.